One of the common questions that comes up when referring to soil tests is how different labs report the analysis. If you send a sample to Oklahoma State University Soil Water Forage Analytical Laboratory, you're going to get reports in terms of pounds per acre for nitrate, calcium, and magnesium, and you're going to get in terms of soil test phosphorus and ppm for things like phosphorus and potassium. One of the most common questions we get when looking at soil test reports is how do we tell the difference from one lab to another? If you send a soil sample to Oklahoma State University Soil Water Forage Analytical Laboratory, your output's going to present in terms of nitrogen, calcium, magnesium as pounds per acre. For phosphorus and potassium, you're going to get two values. One will be soil test index and the other will be ppm. If you're to send your sample elsewhere for like Ward Lab or Servitec, you're going to get all results in ppm. They're really, if you use the same analytical procedures such as Malik 3, they're the same answer. We just have to look at the conversions. So we're going to go through quickly how to convert ppm to soil test index or vice versa. One thing that first takes an understanding is that we look at a sample of soil, especially at OSU, the recommended sampling depth of 0 to 6 inches. So 0 to 6, also referred to as the acre furrow slice, has approximately 2 million pounds of soil. So in 6 inches, there's 2 million pounds of soil. When a lab runs a soil test and they're running an extraction, looking at how much phosphorus, how much nitrogen, potassium is in the soil unit, all these labs actually get results in terms of ppm or parts per million. So the easy conversion when you have a 0 to 6 inch sample, if you have 10 parts per million, you have 2 million pounds of soil, so in a 0 to 6 inch sample, you'll have 20 pounds per acre. And so you'll look at your OSU soil test report and see that you have a soil test phosphorus of 5 ppm. That means you have an STP, soil test phosphorus index, of 10. Or if it was nitrate, you'd have 10 ppm, you have 20 pounds. Now this is where we have to start being very careful when we start looking at the reports. So if you get nitrate from another lab, say Ward Lab, and it presents you have 10 ppm in NO3, soil sampling depth becomes very important. Multiple consultants may use a different depth. So depth in this case really does matter. I look at some quick conversions. So in a 0 to 6 inch sample, you multiply by 2. That means 3, 9, and 12. You have multiplication factors of 1, 3, and 4. So if your consultant has pulled a 0 to 9 inch sample and you have 10 ppm nitrate, that means you have 30 pounds of residual nitrate. If it's 0 to 6, that means you have 20 pounds of residual nitrate. Just being off a little bit can really impact you. So this 10 ppm from a 0 to 8, if you interpret it as a 0 to 6 inch sample, it would tell you had 20 pounds. But in actuality, a 0 to 8 inch sample, you would have 26.7 pounds. If it was a 0 to 4 inch sample, you would actually have 13.3 pounds of nitrate. This goes back to the importance of understanding your sampling depth and why that matters when it comes to making nitrogen and sulfur recommendations and understanding soil test phosphorus and soil test potassium index when OSU presents both the index and ppm. It's actually just a factor trying to take into account for how much soil there is and giving you an idea of how many available pounds of phosphorus and potassium there is in the soil. For more information on this, check out the SunUp website at sunup.okstate.edu.